The reason why figure skaters are able to perform such pirouettes is the same reason why a day does not always have exactly the same duration. At the beginning of the spin, she turns slowly, and then, as if out of nowhere, she gains a drastic boost in rotation. The skater has full control over her rotational speed through her arms. With her arms extended, she spins slowly, and the closer she pulls them to her body, the faster the rotation becomes. She can slow down again by extending her arms outward. There is no simple explanation for this. We need to look at the formulas. The hands have a certain angular momentum. Momentum is what we commonly call impulse, and without external forces, which on an icy surface with very little friction are practically non-existent, the momentum does not change. One of the factors is the radius. Another is the rotational speed. If the angular momentum must remain constant and the radius decreases, the speed must increase. In other words, the closer a given mass is to the axis of rotation, the faster it moves around it. And the opposite is also true. This can be easily tested on an office chair. And since momentum equals mass times velocity, the effect works even better when holding something heavy in the hands. The Earth behaves in a similar way. In autumn, trees lose their leaves, and in spring, new leaves grow. Thus, a certain amount of biomass moves several meters away from the Earth's axis and then returns. Although spring and autumn are always opposite in the northern and southern hemispheres, the northern hemisphere has much more landmass. All the foliage of the northern hemisphere's trees, subtracted by that of the southern hemisphere, still represents an immense mass. If we disregard many other factors that also alter their distance from Earth, such as shifts in the distribution of water and ice or mass movements caused by earthquakes, then the Earth must rotate a little faster after the leaves fall in late autumn than in spring. Another example comes from the tides. The moon exerts a gravitational force on the oceans, causing huge masses of water to shift periodically. This movement not only changes sea levels but also redistributes mass on a global scale, subtly affecting the planet's rotation. It is a tiny effect compared to a spin on ice, but enough to be detected by extremely precise scientific measurements. Thus, both a skater controlling her arms and the planet dealing with leaves, ice, and oceans are subject to the same fundamental law, the conservation of angular momentum. See you in the next one.